opportunity to speak today. I'll definitely talk a little bit about Seismic as a company and the product that we're bringing to market, but the title of my talk is, as you can see, Robotics Has Barely Started. And I found myself throughout my career representative of robotics in many kind of interesting ways. So I'm from a big family. I'm the oldest of 8. My parents did go to college. I'm a first generation college goer, and then I went into engineering, and then I went and did a Ph.D, and then I went into robotics, and I go home and nobody cares. And they actually hear kind of just what people hear in the mainstream about robotics. And then I went and had this family, and I'm the father of 6 kids, and guess what? None of them are engineers either. I go home and nobody cares. They're really interested, but I always find myself surrounded
in my non-professional life, in my personal life, by non-engineers, and I also find myself talking about like robotics and technology and in like the way that mainstream media and other channels talk about it. So in my career, I've often found myself being this kind of representative of robotics from that point of view. And then the other part, as I go through the kinds of things that I've done, is that you'll see this this kind of track of doing rehabilitation applications of robotics, stroke therapy, coming to the Valley to a place like SRI, a nonprofit, founding Silicon Valley Robotics, and it's also just part of my makeup and my own ambition. I think I'm just like the classic engineer. So I meet so many people, engineers that just want to do something valuable with their engineering background, and so I've found myself exploring robotics and my profession from that perspective. How can we do something impactful and useful with robotics? And I'm often just surprised at how much doesn't exist, how much impact robotics hasn't made given all of the hype. And so that brings me back to the title, like robotics has barely started. So from this perspective of wanting to make an impact, but then also finding myself constantly being the sort of interpreter for what's going on with robotics. So I'm going to jump in and I have 3 different parts in my talk, and starting out, just this general idea. You guys all have seen, I know I've looked at some of the previous talks that have been given, different robotics professionals have come in, and there's a background of what's a robot, how do robots work, what's going on. I'm going to try not to do too much of that, but I did want to show this slide, and I know that this slide is about 13 years old, because this is a slide I showed my son's kindergarten class when I was asked to come in and give a talk about robotics, and that son, Declan, is now a junior in high school. And it's just this idea that what's the difference between a robot and automation? And a robot is able to sense and think for itself. There's a human an interface, and then it's doing something, and it has the ability to change what it does based on what it's thinking and sensing. And then there's all of these other sort of views of a robot, and I kind of pulled out the idea that it's programmable, it uses sensor information, and this last thing, that it does functions normally ascribed to humans. And this is where like the problems start when you're having dinner with your friends who don't know anything about robots. And then there's a problem too, like why would we want a robot to do something? And like sometimes we don't want to do it. Sometimes it's dangerous. We don't have the time to do it. We want to be able to have something do things for us in a quality way. And sometimes robots can even do things better than we can. And so these sort of 2 slides that I've pulled from old presentations that I've given give my view on robotics. But I also tell my children that if they're ever stuck at a dinner party with a bunch of my robot friends, that they should just sort of casually say, well, what do all of you think about, what do you think a robot is? And then just sort of step back and let the the conversation go. So people are always classically debating what is the beginning and the end of what a robot is. So I wanted to share this slide, which is part of my background work. I mentioned I'm doing robotics for stroke rehabilitation. My very first job in robotics was actually working in a Department of Education funded Rehabilitation Engineering Research Center at the DuPont Children's Hospital in Wilmington, Delaware. It was a collaboration with the Computer Science Department at the University of Delaware. And I was working on the gym floor with kids with a range of disabilities, trying to figure out how could we use robots to create better educational experiences, life experiences. After doing that for several years, getting my Ph.D. at Cambridge, I came back and was ultimately recruited to be the US general manager for an Israeli startup, where we brought this robot to market. And this would have been in 2004. And like I see all this stuff out now about cobots and people working with robots, and like this is what I was doing in 2004, putting a person with a stroke in a robot like this, and it's basically a big joystick that someone would sit their arm in with force sensors, and as they're trying to recreate their motion based on visual cues, the robot would assist or resist to help with that repetitive training that helps someone recover from a stroke. But this gives a good insight into the kind of background that I have in robotics, is wanting to do something that's commercially viable. So we brought this to market, brought it through the FDA process. There's probably 300 to 400 of these in use around the world right now. And I actually think that there should be much broader use of this kind of technology. But I learned a lot about robotics from doing this, and I'm going to call out some of the things that I learned as I keep going forward. One of my best experiences I had in robotics was I came to California just about 10 years ago. I was recruited to be the Director of Robotics at SRI International, and I think that we were the best kept secret, not just in the Valley in robotics, but in the world in robotics. So this is 65 people. We had, when I arrived, it was the smallest program at SRI, losing money. When I left, it was the largest program at SRI, and just had a great energy and a lot of contributions. So most people know about Intuitive Surgical coming from the robotics program at SRI, and then another company, Artificial Muscle. But in the time I was there, we also spun out or did Redwood Robotics, Grabit, helped start Silicon Valley Robotics, Abundant Robotics, Verb Surgical, and in Seismic, which at the time we had called Superflex. Verb Surgical we built actually here. We also built the Yamaha's Motobot, which Yamaha didn't let anyone know that until a few, maybe 6 months after they released it. We built the platform for J&J that they brought to Google Verily and are now commercializing with Verb Surgical. Recently we announced this robot miner with a Chilean mining company called Enaex, and one of the few new licenses to harmonic drive of a completely new kind of gearing system that all came out of our lab, and then we spun out these companies. So the reason I'm showing you all of this is because for me, going back to the idea of wanting to make an impact and coming to a place, that was what was really attractive about coming to a place like SRI that had a history of commercialization, an organization in the robotics lab that had the heritage of the Vinci Robot Intuitive Surgical spinning out. And I feel like this was a really great accomplishment and making an impact in robotics by getting real technologies out into the market. But I want to talk a little bit about that impact and what it really means to make an impact, and where is robotics in terms of the impact it's actually making today. And so I've been thinking about this for a while, and I recently came up with this graphic to help describe the impact of robotics, and you could probably use this for a range of technologies. But so on your far right, impact in terms of sales. So I know there's impact in other ways, and I'll debate that with you if you want how to show it. But let's focus on sales for right now. And then technical capability. In robotics, it's general purpose, flexibility, extendability, and then for low technical capability, something that's low function, single purpose. And so anything to the right is going to be a product, right? We have sales in the market. It's greater than zero. We have one sale. Anything to the left is going to be R&D, product development, hopeful consumer impact, but there's still like large commercialization risk coming from that side. So now let's just pick a simple example of a car, and this is in 2018 only. I think the worldwide sales of cars was in the 80 to 90 million range. So that gives an example of a consumer product that's mature, that's in the market, worldwide, is selling at that level. But now I'm going to contrast that with a robot that is well known to everyone, C3PO, and I'm actually putting this down here at low function, single purpose, because it's actually just an entertainment robot. It's actually not doing anything as a robot, and it's really just a concept. So if we keep following this, I'll show just a few more examples of where I would place different robot solutions. So industrial robots, and this is a good example of something that's low volume. Like the total install base of industrial robots in the world is something like 1.4 million. And so I love the headlines that say that robot sales are going up 30%, and it's like 300,020 versus the 320,000 versus the 300,000 from the year before. Like the numbers are still relatively small. And yes, industrial robots have a much bigger impact that I'll talk about later beyond just their sales. But that install base, I think, is surprising to people when you think about just the amount of knowledge and attention there is around industrial robots. So another robot that gets a lot of attention is Atlas. And here, this is a significant R&D robot. The capability of this is very significant, but it's still, from an impact point of view, it's still research, it's still development. It's not something that is on the market. And this is a robot that we worked on at SRI, which I would even put further to the left in that scale. Pepper, staying in the humanoid theme, is something that's actually had reasonably significant sales, but it's actually doesn't have much capability at all in terms of a humanoid. It's basically just a stand for that pad there. But now we're starting to see how to judge the impact of these different robots. And Vinci, as a solution, is also relatively low capability. It's actually designed to reflect the skill of the surgeon, so it's not doing that much autonomously. And still relatively low sales, again, for the knowledge of it. Roomba is a really good example of something that is probably the best-selling robot that people think about. It's now, in some countries, it's the #1 selling vacuum cleaner. So I think it may even be worldwide the top selling vacuum cleaner in that category. But it's relatively low functionality. So now let's start assessing what's going on here. And so down in this bottom left-hand corner, and I'm telling you all this because these are my dinner conversations when I go out with friends and my family. Is they want to talk about entertainment robots. They bring up all these things, and I just want to educate people and get people thinking about like what's a real robot, what's actually impacting the world versus what is just entertainment or otherwise. And so down here, these robots get a lot of attention, and this is something that's really interesting about being in robotics is the fact that everybody knows about them. People have read about them, people have seen movies about them, but when you actually try to talk about what's real and not real, it's actually pretty hard to explain. So a lot of attention for these kinds of robots, but they're not real. And then the other thing that you see is there's also a lot of attention for these research robots. And this to me is like, it's a little pet peeve of mine, is the amount of attention that research outcomes in robotics get relative to other fields. Like I just think that somehow there needs to be some kind of a warning label when research press releases come out that just says this is in Rich Mahoney's upper left-hand quadrant or something like that, because I think people see them and they think that there's more closer to the market than actually exists. And at some level, I feel like robotics is not fully understood, and that all of this activity on the left side of this chart is somehow contributing to the confusion that people have about what robotics can be, the impact that it can really make. So that actual market current value is what I'm showing here in the middle, and it's actually really low impact. And this to me is the main point of this robotics has barely started. There's a small set of technologies that you can call robotics that are actually being sold and impacting the market. And I would say that this bottom low function single purpose is where the emerging value is. You can see there's other kinds of robots with simpler solutions, and I'll talk about where some of those are coming from. But I think this is where it's going to be starting. But that future, that transformational opportunity, that impact of robotics that people are excited about and some people are afraid of, is really way up in that upper right-hand corner. And there's not that much that's going on. And you could almost say that there's nothing going on there yet. But ultimately, that quadrant is going to be entered either from the right as those, from the left as those technologies get validated and move to the right, or where technologies that have lower functionality are augmented. And it's something, for cars, for instance, that's what's happening now, right? Cars are getting a lot more capability, and they're moving up into that more general purpose category. So the other thing to think about when you look at that product development is that it takes a while for technologies to move across from the left to the right. And so I'm living in this phase of things right now, from seed funding to Series A funding to product market fit to growth funding. And this is the other part of robotics that's interesting to me. What's real, what's not real, and it's very challenging to get the investment that you need, demonstrate a real product, bring that product across each of these areas. So, but in general, this is probably a more technically oriented audience, and I don't know if you think this is useful or not useful, but I found it to be tremendously useful in my interactions with the world. And it's also just helping me deal with this this issue that I was describing in the beginning. So I think we need to be more aware of what's real, what's not real, and what impact has actually been made. So from that point of view, this is all the technologies I showed you in those nice columns that came out of my lab at SRI. This is where I would put them on my chart here. And so now I'm pissed because I've been working in robotics since 1988. I started as a master's student. So if you do the math, that's 30 plus years. And I even just had this great run at SRI, and then look at the impact, right? There's still not that much impact and that's part of the reason that I actually decided to leave SRI. And I thought I love the job there. I think it's a great place to be, but I was still driven to want to be involved in making real impact with robotics. And so the next video I'm going to show you is an introduction to the product that we've been developing at Seismic, and this was based on we had a DARPA program called Warrior Web, which was focused on wearable solutions, wearable robotic solutions that were alternatives to exoskeletons, more lightweight, more focused on injury mitigation and fatigue reduction. And we had developed, I was the PI for that program. We developed a few component technologies that I thought were really compelling, and you can see now the company that we created from that.
When I close my eyes, I see the trail, and I'm done wishing I was back out there, done thinking those days are behind me. I needed a shift, and that shift was Seismic. A fusion of Redwood Robotics. I drive to get up and out there. The confidence to stand tall. And the energy to keep going. My feet are back on the trail, carrying me onward to what I love. Finding that perfect shot. That feeling, that's Seismic.
So the product that we created is really differentiated from exoskeletons as something that's lightweight and more clothing-like. And the big insight that drove us really early on, there's really two things. The first was that people don't wear robots. So what are they wearing? They're wearing clothing. And so we took the perspective that we have to think about ourselves as clothing innovators. How do we add functionality to clothing while maintaining the people's relationship with clothing in terms of comfort and aesthetic and emotion? And so we really view Seismic as a new category of clothing, and we refer to it as powered clothing. And then the other insight that we had was how do we take these robotic muscles that we developed at SRI and apply them to the body? Which part of the body do we want to support? What's the use case? And we decided very early to look at the world's aging, the aging of the world, and what were the challenges there, and saw mobility and as limiting quality of life, and that mobility comes from core strength, hip and lower back support. So we developed a suit that we call powered clothing for core strength, and the pointer here doesn't work, but the patch that you see on the left leg contains a muscle driver for a muscle. The center is battery, and there's actually a hip flexor in the front, a hip extensor that aligns with your glutes in the back, and then the patch on the lumbar is also actuated to support the lower back. So this is a fully programmable suit providing what we call intelligent wearable strength. The initial focus, I've described to you my background in rehabilitation technology, and we decided early that we wanted to make something that was more consumer facing, something that was more focused on consumer wellness. And so our initial target was intelligent wearable strength for core support, that's something that could be used in the aging population. And we have some initial work that we've done in partnership with retirement communities to demonstrate that product. And I'll talk a little bit more about the status. So the functionality, as I just described, you can support in a programmable way, in a way that you control the attention and support to the lower back. And you can also actuate muscles in parallel with your own muscles in a way that either provides additional stability. So think you're on a boat just trying to stabilize yourself, and you have controllable support within your clothing. Or it can actuate fast enough that it can actually help to propel your body if you're, for instance, getting up out of a chair or walking, something like that. So these, the initial application is for mobility support for consumers, and the idea of a programmable suit means that we can also look at other kinds of applications. And one of the things that we found as we were following this path from spinning out of actually doing the first R&D work under the DARPA program in 2014, spinning out in 2016 with seed funding from Horizons Ventures and Root Ventures. And then just recently we've built the first 30 production versions of this. We're finding that the entry into the market, into the consumer market is going to take a little bit longer, and we have a lot of interest and demand for worker safety, same application, wearable strength around the core, and so we're beginning to spend more time focusing on that as our transition for construction jobs and other kinds of service jobs. And that's actually, there's an interesting kind of partnership that's emerged for us. There's a company called Cintas that you might know. They're a public company based in Cincinnati. They provide leased uniforms to tons of major companies across the US. And there's an interesting opportunity for us to work with them. And similar to how I was saying that cars are getting more capability and moving up into that right-hand quadrant, you can think about how work uniforms can be seen as having increased technical capability, and in a similar way moving up into that quadrant. So partnering with Cintas is going to help us move faster into that area. And that's our general status right now. We're just entering the market. We're just transitioning from the R&D phase into first production, and we'll be targeting our first placements at the end of this year and into next year around employee health and safety. And as we put those in place, we'll do more announcements around them, but that's our general status. So just to summarize in this part one, and the other two parts will be a little bit shorter. So just in terms of market penetration, actual robot sales are quite small, just black and white. And the hype of robots in R&D and media and entertainment create a false impression of progress. So these to me are things that I try to communicate to friends and family. And I do think at some level it impacts public perception. It impacts even investment and the number of people that will do startups. I think there's some sense that there's so much there, or it's hard somehow, but I'd like people to be more aware that there's still a lot of work to do to make robots more available. So now I'll talk about a couple of trends which I think are driving the direction of robotics short term. And so this is something I've shown, if any of you have seen me talk before, this is something I always highlight, the fact that robotics is really part of the technology continuum, and that many other technologies and technologies that people in this room have developed in terms of communication, perception, processing, and mobility are actually becoming commoditized and form our key components for robotics. Our powered clothing product is, I would say, 90% off-the-shelf components. There's a lot that we're able to take advantage of in bringing that to market. And then we have just certain areas like bipedal walking that's starting to emerge, manipulation, which is starting to emerge, awareness and intelligence interaction just starting to emerge. It's another area that gets a lot of attention and maybe sometimes is overhyped. And then power is really the big, I think still the big need area. I tell people all the time that we can do pretty much everything in the Iron Man suit except for one thing, and that's the arc reactor. So if we had that arc reactor, we could probably do everything else. So power is still a big limiter. And so in terms of other trends that we're seeing is mobility has now become quite commoditized, and so we're starting to see drones and mobile robots as a very accessible robotic technology, and we have the ability of teams to apply themselves to that platform, and so that's why we're seeing so many kinds of solutions. So in addition to cars as a mobile robot technology, this is an area that is getting a lot of attention, but partly because the hardware has become commoditized. And it's kind of, when I look at the stage of things, I see us now around mobility as commoditized. This sort of perception, processing, communications hardware is already there, and we're just beginning to see manipulation solutions that are becoming more commoditized. And the more that these hardware platforms are available, the more that able people are to begin to apply them to business solutions. So there are a number of, you'll see a number of sort of workstation type solutions for coffee making and food processing that are using robot arms. And all of that is coming now, and I think we're going to see in the next less than 10 years that become very commonplace. We're going to see mobile robots and these workstation arms in a number of applications. And I do think it's just a matter of time before that extends into humanoids and more general purpose solutions. And people will say, well, will that ever happen? And to me, it's not a matter of will, it will definitely happen. And is it 25 years or 50 years? And usually what I'll do is I'll say, well, do you think in 100 years it will happen? And most people will say yes. And then you just start working backwards. And to me, it doesn't matter if it's 100 years or 50 years or 25 years. At some point, that those hardware platforms are going to emerge and be commoditized, and they're going to form the basis of more and more businesses and business models. The other big thing, and I've been talking about this for a long time, is that we spend, the robotics gets a lot of attention for its potential to displace workers. And the reality is that right now, the bulk of attention with robotics is focused on solving the labor shortages that are occurring in the service industry. And so it is very common. And one thing I always highlight is manufacturing is actually a service industry, people making things for other people. And it's the one that got the most attention from robotics so far, but it's still a service industry. And even there, we're seeing a lack of workers affecting the implementation of robotics. And so, and this is really true in terms of the kinds of companies that are emerging. So you're seeing from a service point of view, commercial kitchens, restaurants, agriculture, medical, surgical fields, all of these are getting a lot of attention as far as robots that are helping to fill labor gaps and provide higher quality kind of outcomes. And coming back to my chart for just showing status, I generally feel like they're falling into these kinds of areas. So still very early. There's a few that are making it to market. Maybe this has shifted a little bit to the right, but it's still just an emerging set of companies and capabilities. So I do think restaurants, the food industry, agriculture is really interesting. If you think about how our population has transitioned from mostly agriculture to like 3 to 5% agriculture, and even that percentage is going to shrink dramatically given the way that we're applying robotics now. So, so I do think there is a need for more work on robots that make a real impact. One of the things that's true is that companies are still making their own robots, so you don't see that many, even for mobility solutions that the components are commoditized, you don't see too many people pulling an off-the-shelf mobile robot and applying that for a business. And then personal solutions are still dramatically missing. There's not a lot of home robot solutions that are out there and successful. So my last part, this is something I'm constantly facing, is this idea that are robots going to hurt us? Are they going to take us over? And I don't run away from this. The reality is that every single solitary technology that humanity has ever developed, we have turned on ourselves, 100%. And even the written word, even tomatoes, like even information technology, right? So this is what we do. So for anybody to think that that's not going to happen with robotics, you're deluding yourself. So 100% we are going to find a way to turn robotics against ourselves. And so it doesn't mean that we shouldn't move forward with robotics, but we should be fully aware that it's going to happen, and it shouldn't even be a conversation about will it happen. There's nothing that we've ever done that we haven't done this. So, but we do always respond. We always regulate when we see the problem. One of my favorite books is It's called The Age of Edison. It's about when, after the light bulb was invented, how the US became electrified and what was going on in the world around electricity. And it's really astounding that there was no regulation. There were fires being started. There were telephone or electric poles falling into crowds and electrocuting people. And over time, we saw the benefit of the technology, saw the challenges, built regulation, and now electricity is a utility. Everybody receives it. So I think for technologies in general and for robotics, we're going to go through that. So I brought a robot to market through the FDA. Robotics are regulated. There are already regulations that people need to follow. But I do think in general, and you can see this in my tone, that, and it's part of my mission as someone working in robots, is to tell more good stories about what robots can do. And I learned this, it was from this Brian David Johnson, who was a futurist at Intel. I think he's moved on from there now. But I thought he was going to give a talk about the future, or what's going to happen. And instead, he talked about this idea that as a futurist, you're not predicting the future, you're helping to influence the future. And that really stuck with me. And so I do see myself as someone working in robotics, trying to influence the future. And one of the big insights for me that I think is overlooked with robots is that robots are creating value for the world in ways that I don't think are being recognized. So here's an interesting chart. If you look on the left is the new employment in goods and services. So this line along the bottom is the manufacturing of goods. Almost no new employment is happening there. And part of the reason is because automation is being applied. And then you can see in service industries, tons of new employment. That's where all the but we know that more employment, more labor means more cost. And so we see some interesting trends on the right. So manufactured things like toys, furniture and bedding, cars, apparel are actually dropping in relative cost. And I like this chart a little bit better. You can see in sort of the mid 80s that durables started to level off, and in real terms are actually cheaper than they were in the mid 80s. But those services continue to increase in price. And so that's directly related to the introduction of automation into the manufacturing sector. So what can happen if we start to introduce automation more into services? And one of the things that I think is overlooked is that, yes, manufacturing jobs are impacted, but how many people were able to access high quality durable goods at a lower price? What was the value to the world of all of that capability? And when we look at healthcare and we look at other kinds of services that people are not able to access, that's a missed opportunity with automation. And so if you look at, I really like this recent innovation from iRobot. I actually bought my first robot personally just at the beginning of this year. It was the new Roomba with the mapping software, because I finally saw something that I thought should exist in a robot. And this is really pretty awesome software. You put the robot down, say clean, and within a couple of passes, it's fully mapped your house. And I immediately saw that this created lots of ease of use, and now I can say clean the kitchen, clean the bedroom, but that map is now an available resource to build other kinds of applications on. So you could imagine selling carpet, a carpeting company could give you a quote based on knowing your layout, or a painting company, or other kinds of mobile devices could be integrated into that mapping solution. And so I think similar to the mapping that's happening outside of our homes and streets, Roomba is introducing a capability here that is actually now expanding the application space. And I think about this, if we go back to, this is a Taurus robot, which is a variation of the Da Vinci that we developed for bomb disposal. But one of the things that we were looking at is this idea that as a telemanipulator, there's all this information that exists. And what's interesting is that there's a person who's controlling that robot directly, but every bit of the input from the person is being captured, and every bit of interaction that the robot is doing is being captured. There's tremendous amount of opportunity to learn from the human controller some service orientation. And one of the things that I've always not understood is the Vinci Robot, for the number of surgeries that have occurred, that we have every movement of the surgeon, every movement of the robot, a camera, the outcomes measurement of the person's recovery. We don't seem to know much more about surgery, and I think that's something I'm excited about. Verb Surgical, this platform that I mentioned we developed for Johnson & Johnson while I was at SRI, we helped to seed with them some of these concepts of how can you use that information. And so Verb Surgical is very clearly talking about democratizing surgery by using that data, and I think it's actually a really brave and compelling, and imagine the quality of surgery being understood at a level where it can now be conducted across the globe. Doesn't matter who your doctor is. I always have this, I'm sorry you're getting all my pet peeves, I hate when we rank children's hospitals, or someone says, oh, I'm the #1 children's hospital. And then I'm like, well, what about the #10 children's hospital? We just actually told the world that it's okay for us to have our children get lower quality medical care. And I think robotic solutions following this path let us capture quality and deliver it in a way where we don't have to do that anymore. And that's really my biggest insight around robotics, is that this mix of sensing, thinking, learning from people, it creates actionable physical knowledge that's new. These are data sets that don't exist, and that this knowledge captures the quality of services that can be delivered by the same platform that documented the quality. Again, this is something that just hasn't existed before. So to me, whereas the internet democratizes access to information, robotics will democratize access to quality physical services and ultimately broadly available quality of life. And this to me is that good message that I think isn't being talked about. And maybe it takes, I think I'm going over my time, it takes an hour to get to this, so that's why I need to figure out what a media bullet looks like. But this to me is a fundamental, my fundamental motivation for wanting to work in robotics, and the opportunities I think that exist in this field. So that's the end of my talk. Thanks very much for the opportunity to present these ideas to you, and I'm happy to take any questions if we still have time.